Hi guys, welcome to the workshop. We're going to have another look at our step-by-stepper setup. Even today there seems to be a lot of questions on it, can't get it to work, and all those sorts of things. What kind of a circuit? The circuit we're going to use was the one we've seen in the last video, and it is John Bedini's schoolgirl circuit, the SSG circuit. That's all it's going to be, as messy as you like. Your 1k pot, 100 ohm resistor. I'm using a tip 3055, I think that one is. Yes, tip 3055 transistor. You can use a 2N3055, any high powered NPN transistor, medium to high power, depending on how hard you want to drive it. And of course just our diode here, diode across our base emitter junction, and our little neon across our emitter collector, and of course the diode which comes from the negative side of your coil, or the side that goes to the collector. This diode would normally be on the collector, but I just stick it in there, it doesn't matter where it is, as long as it's on the collector, and our current can flow out of that diode and over there into our charging cap. Right, so we've got this stepper motor here. This one you'll see has 4 coloured wires, and then it has 4 white wires with coloured stripes. Those ones we don't have to worry about, they are simply for the what do they call those little buggers, the sensors in there, Hall effect sensors. So we only want the 4 coloured diodes. Now you'll probably find that the pairs are going to be, our 2 hot wires of course will be our red and our orange, and our 2 cold wires are green and black. So either the red and the green or the red and the black should be one coil set in this case, and we're simply going to put our multimeter on there, set to ohms, and when we get the right one we'll know we've got one set of coils, if we can get the right one. So the multimeter's reading nothing there, so obviously it must be the black one. This alligator clip needs thrown in the bin. There we go. So we've got 25 ohms, so that must mean that our green one here and your orange one, and of course the wires one sit flat on the bench for a change, must be our other coil set, very stiff wires, 24.6. So that's our coil set, black and red, orange and green. And you'll probably find that if you use your red for your drive, so that'll go to your positive, and your black one here goes to the negative side, which will be the collector, the orange one to your base, and the green one to your ground, it should work. Those coils should be in phase. So we're going to go ahead and put it all together now. Can't do that one-handed, and we'll come back and have a look. Okay, so it's all wired up. Now I found out something interesting that I didn't realise last time, was it doesn't matter which way you have these wires around for the trigger. You have them one way, it'll spin in one direction. If you have them the other way, it'll spin in the other direction. So that's pretty handy. So you'll see on our load there, you'll see those LEDs there are still going quite brightly. That's across that 10,000 UF cap, and that is how fast the voltage is dropping on that cap. So once LEDs drop down to a certain level, they draw bugger all, absolutely nothing. But anyway, we're running on 15 volts. It's our current meter, and our stepper's all set up ready to go. And I would imagine that if we swap the 2 wires around for our run coil, or what we're using for our run coil, it would spin the other way as well. So as long as you've got the 2 pairs separate, you should find that the motor is going to spin. Our scope is hooked up across collector emitter, just so we can see the frequency. We'll turn the pot right down. I've only got a 1k pot on here. I reckon I might change it for a 5k, get this thing really cranking. As you'll see, the more we wind the resistance up on the base, the faster it spins. But it's just a matter of giving a little tap like that. You hardly have to touch it. Just a little flick and away it goes. And now our LED is thumping. So that's the inductive kickback coming from our little motor. Our frequency at the moment is 273 Hertz, and reasonably square wave except for the little dip in the centre there. So we'll just turn that back on. But now we're going to wind our pot up, and unlike the SSG, you'll see that when we wind the pot up, it may go faster. Do draw more current. You'll see this point here is that's the pot fully open. We have 1k of resistance plus the 100 ohms across that, so 1.1k of resistance across the base, and I reckon we could go a lot better than that. So drawing 86-87 milliamps at our 15 volts. Now the thing I noticed is the voltage across the LED doesn't really change. Even if I put a load on the motor, as you can see, the heavier we load the motor, the more power goes to the LED till it stops. Oh. So that's the motor unloaded, so I'm going to load it. So the voltage coming out of it on our kickback side is reasonably stable regardless of load, which is good to know. And our current goes up about 24 milliamps when it's nearly stalled. 813 Hertz now. And you'll see that centre dip. It's come right down to 0 volts now. But very easy to start. Oh, now it's really humming. I don't really know where that noise is coming from. It's actually coming from the motor, not the transistor. For some reason it wants to squeal now. Actually, I wonder how that would go in self-oscillation mode. I'm going to, where's my pliers? I'm going to cut the, over here, I'm going to cut our diode between the base and emitter, like so. It should normally send it into self-oscillation, so we'll see what happens when I give it a flick. And now it goes faster. 909 Hertz. Now normally when you do that with a pulse mode, if you stop the rotor it'll keep self-oscillating, so we'll see if it does the same here. Nope. Okay, so in this case, with this particular stepper motor, we do not need the, geez, that LED's bright, we do not need the diode across the base emitter junction. So what I'm thinking now, because that's got a fair bit of torque, actually with that diode cut off, I can fully load it till just about stall like that. And you only go up about 5 milliamps. so that diode can stay off in this case. That's not bad. We can load this right down, only draw 5 milliamps extra and have no effect on the output, which is quite good actually. So I think what we need here is to mount this to the board and mount a big rotor to it. Now, just so happens to be throwout day around this place, and I found inside a washing machine a motor that I have not seen in any in Australia before. This big U-boot rotor. These are actually magnets and quite strong, and I reckon that'll fit on there quite nicely. And the reason that might be the way to go is because it also came with the rest of the motor, which is this part here, very large generator. Now, something's a little odd. We have 10 magnets and we have 12 stators, so I'm not sure how that works out, but it looks like it is a 3-phase configuration, although 3 does not go into 10. I would have thought that perhaps maybe 9, but I'm not sure how they get each one of these, or a set of these in each phase, in line with a set of these. But anyway, we'll have a look at that. I think that is going to be machined up and go straight on to our stepper motor. That'll be in the next video. So there you go guys, simple as that. Fairly low on the current draw. Definitely not going to cook your transistor with this one. Transistor is stone cold. Plenty of output on the inductive kickback side. As you can see, probably not very good for the camera that. Yeah, it works a treat. Speed controllable. And the good thing is when we wind the base down it doesn't draw more power until we get to that stage. I'm just going on there because that didn't do that with the diode across the base emitter. Now look, going up to 12 volts across that LED is absolutely tonguing now. That is full power for that LED. 133 milliamps. I'm actually going to put that onto my power supply through the amp meter and see how much that draws at 12 volts. Alright, been fun. We'll see you next video and we've got this all mounted up. Cheers.